Hello, ladies and gentlemen. Today we're going to be starting a new unit, Unit 3, and that is transformations of shapes. And the first thing of transformations are translations. This video is provided if you are not in class. Otherwise, we will be doing these notes in class. So if you miss class, this is why you're watching this video. So all you'll need for this video is a note sheet that you could have gotten from me in class. You don't necessarily need it, and a pen or pencil. So our new unit on transformations is transformations of shapes or figures on a given graph. We'll see some examples on later slides, but first let's define our first type of transformation, which is a translation. And a translation is a type of transformation that slides each point of the figure in the same distance and direction. So first let's note that this type of transformation is congruent. It's a congruent transformation. So if you want to add that to the definition, that would be good. We say that it's a congruent transformation because the shape shouldn't change anything other than its location. It would start on, if you think about a shape on a page, it would start at like the top left-hand corner and then move down or to the right or up and to the left. So that shouldn't change anything about the congruency of the first image and the second image. So this is a congruent transformation. All right, and there's two ways that we can note or write these translations. So the first way is written down, and this is coordinate notation, where they give us a coordinate point. That should be easy to remember. And coordinate points are always written as x comma y. So on our left-hand side of this little arrow, x comma y is any point on the given graph or on the given shape. And then on the right-hand side of this arrow, this is the rule of how we are to move the image or the shape. So we're saying x plus a, y plus b. So that's in the direction of the x-axis, a units, and in the direction on the y-axis, b units. So let's look in this little box for an example. So we're saying any x and y point on the shape, if we were to have that mapped onto a graph, we are moving it, this mapping specifically says on the x-axis in a positive 6 direction. So that means that we would move our shape right 6 units. And then if we look at our rule for our y-coordinate, it's saying that we're moving on the y-axis in the negative direction 2 units, which on our graph would mean down 2 units. So that's what we mean by coordinate notation. So remember that translations are just sliding an image from one spot to another. So they're congruent shapes, but yet we're just moving them to the right or left or up or down. And how we write that can be in coordinate notation or vector notation. So vector notation is something new to us, and we'll talk about it as the year goes on. But whenever we do anything with vectors, so that they're not confused with coordinates, instead of writing parentheses, we write these arrows so that we know that it's in vector notation rather than in coordinate notation. And instead of saying this mapping like the coordinate says up here, instead of doing this, we're just going to write the value of A and the value of B, or our movements. So if we look at the movements in our box, we're saying that we're moving to the right 6 units and we're moving down 2 units from our original image. Every single point on our shape is moving to the right 6 and down 2. So how we would write that in vector notation would be just like this. And we'll get used to that as we go on. So let's look at an example. So in this first example, we're going to translate the triangle JKL left 3 units and up 4 units. So let's first start by writing that in coordinate and vector notation so we can get used to that. In coordinate notation, we're saying we're moving every XY coordinate left 3 and up 4. So when we say left 3, we're moving in the X direction or on the X axis negative 3 units, because that's what it means by left, right? In the negative direction. So in our Y would be up 4 units. So that's positive 4 units. So That's how we would write it in coordinate notation. If we wanted to write it in vector notation, remember we would start with writing these arrows, brackets, or these pointed brackets so that we don't confuse it with coordinates, and we would be going in the -3 direction first on our x values and in the +4 direction on our y values. We always write our x value direction and then our y value direction. So let's actually do that. Here's point J. So we're first going to move to the left 3, 1, 2, 3, and then from there up 4, 1, 2, 3, 4. I'm a little bit off the graph, but that's okay. When we label these new points now, it's not point J. Point J was over here. We're going to call it J prime, and that's just like J apostrophe. So that's new notation to us as well. But that can tell us then that this isn't the original point of the J coordinate. This is a moved point of the J coordinate. So let's move L now. L's down here. We're going to move left 3, 1, 2, 3, and up 4, 1, 2, 3, 4. So this is our new location for our L coordinate. So we mark it L prime. And now let's do our last point on the triangle K. We're going to move it 3 units to the left. 1, 2, 3, and then from here up 4. 1, 2, 3, 4. And now we're going to label that point K prime because that's our new location for K, the point K. So now you can draw or connect the dots to make our new triangle, and then you can just shade it in. So this is our new location of our triangle JLK. All right. So what if the question had asked us what are our new coordinate points for J, K, and L? Well, J prime would be the coordinates would be left 2, so on our x-axis -2, and it would be up about 1, 2, 3, 4, 5, 6, 7. So our new coordinate for J prime, or for our point J, is -2, 7. And let's do the same thing for K prime and L prime. K prime is 0, 2, and then L prime is -2, 2. And this is just an additional practice of getting used to writing ordered pairs. We're just writing the ordered pairs of our new points J prime, K prime, and L prime. So that's a translation. It just slid a little bit to the left and up. So let's take a look at another example of translating a different triangle ABC. So we're translating triangle ABC right 5 units and up 3 units. So if we want to write that rule or that translation, let's write it in both our coordinate notation and our vector notation. First coordinate notation, we're saying every xy value on our triangle ABC is moving or translating right 5 and up 3. So we would say x plus 5 because right is in the positive direction 5 units, and then y plus 3 because up is in the positive direction 3 units. So x plus 5, y plus 3. If we wanted to write this in vector notation, we would write our angled brackets or our triangular brackets, and then our first value would be +5 and our second value is +3. And this is telling us that we're moving to the right 5 and up 3. So let's do that. Let's start with point A. We're going to move to the right 5. 1, 2, 3, 4, 5. I think that's right. Let me double count. 1, 2, 3, 4, 5. Yep. And then up 3 from there. 1, 2, 3. So this is our new point A prime. Let's do point B now. We're going to move to the right 5. 1, 2, 3, 4, 5. And up from there 3. 1, 2, 3. So this would be B prime. And last but not least, let's move C to the right 5. 1, 2, 3, 4, 5. And from there up 3. 1, 2, 3. And this is C prime. So just like our last example, connect the dots. And then we can shade in our triangle. Color that in. If you wanted to use a straight edge to get these points connected, that's perfectly fine. I just don't have one. All right, and now we got our triangle shaded. Okay, last but not least, even though the directions don't say this, I'm just going to get practice at writing our new ordered pairs for A prime, B prime, C prime, or our coordinates of our new triangle. So A prime is 0, 1, 2, -3. That's its new location. B prime is 2, 1, and C prime would be 4, -3. Okay, if you notice, my triangle isn't very straight, but it's pretty close to the same size. It should be congruent, but remember we said in our definition that translations are a congruent transformation? That's because just by sliding this triangle right 5 units and up 3 units, we didn't change the size at all. So that's why we're saying that a translation is a congruent type of transformation. In our previous two examples that we did, we actually performed the translation. So this last example, we're going to describe the translation that's happening. It's already been translated for us, this triangle, but now we're just describing what actually happened from triangle QRS to triangle Q prime R prime S prime. So we're describing a translation that maps this image to this image. We call the original image, or triangle QRS, our pre-image. And that's just some more notation for you to know, or more terminology for you to know. And then we call our triangle Q prime R prime S prime the image. So pre-image because it was what it was before we moved, and then the image because that's our end result. So when we're describing the translation, we just need to pick one point on the triangle and then follow where that prime of that point went. So I'm going to pick point Q and point Q prime. So from point Q to Q prime, we moved to the right, 1, 2, 3, 4, 5, and we also moved down 1, 2, 3, 4. So we moved to the right 5 and down 4. I think that's right. Let me recount. 1, 2, 3, 4, 5. Yep, and then 1, 2, 3, 4. Okay, to the right 5, down 4. This description is not sufficient enough for us. We want the proper notation, or the geometric notation, to describe this translation. And we have two types of notation that we can describe it in, and that's coordinate notation and vector notation. So I'm just going to do it in both because the directions didn't specify one notation over the other. So coordinate notation, remember, we start with our first pre-image mapping, or xy. Any xy value or coordinate ordered pair of our triangle QRS maps to, and that's how we read this arrow, maps to our shifted values, right 5 and down 4. So when we say right 5, we're moving in the positive direction 5 units on the x-axis, and then down 4 means that we're moving in the negative direction on the y-axis 4 units. So this new rule then would be x plus 5, y minus 4. In vector notation, we just need the numbers. So positive 5, negative 4. And don't forget our little angled brackets or our triangular type brackets. Just make sure you're not writing parentheses. So they're kind of like little sideways V's or 7s or greater than, less than signs. But that's just how we note vector forms so that we can differentiate it from coordinate notation. So that is all I have for you guys. We will practice some of this in class, and if you're not in class, you'll have it as a homework assignment. And then also your other homework assignment is to start on the second video. So I will see you guys shortly, and have a great night.